All right, so we have factoring in general. And what we did so far is we've done see if you can take anything out, count the terms, 2, 3, use a box, count the terms, if it's 4, use the grouping, and then I forgot to write in here step number 4, and the step number 4 is factor completely. So I'm going to add that right in here so that we have them all together, factor completely. So let's go ahead and practice some factoring. So once again, I'm looking here and I go, is there anything I can take out of those? No. There's 3 terms. I'm going to use my box, which kind of was a giveaway here. X squared and 16, or x to the 6th and 16th. Now, I notice there's an 8 here. So I'm thinking 4 and 4 works here. And I have x to the 3rd. Well, x to the 3rd times x to the 3rd is x to the 6th power. So let's see what happens. 4 goes here. X to the 3rd goes here. X to the 3rd goes in these 2 spots. And 4 goes here. And in this box we get 4x to the 3rd, 4x to the 3rd, and when we add them we get 8x to the 3rd. So we're looking at x to the 3rd plus 4, x to the 3rd plus 4. The book will also write this as x to the 3rd plus 4 squared. I will accept both. So I start with factoring. Is there anything I can take out of both of those? And I can. I can take a 3. This is 3 times m to the 4th minus 3 times 1. All right? So when I take that 3 out, I have m to the 4th minus 1. Step 2, I've got 2 terms. I'm going to use a box. Because what I'm looking at right now is the difference of 2 squares. And let me show you what you do again. M to the 4th goes here. Negative 1 goes here. And the only way I can get negative 1 is negative 1 times 1. I'm going to try the square here of m squared and m squared. Because these two make m to the 4th. So if I go up here, 1 and 1, I go down here, m squared, then leave myself a lot of room there, m squared, and negative 1, and I see, well, this gives me m squared, this gives me negative m squared, 1's positive, 1's negative, I subtract, 1 minus 1 is 0, and there is no middle number there. So I must be on the right track. 3 times, and I have m squared plus 1 and m squared minus 1. Looking to see if we factored completely. Nothing we can do here. Oop, there's a square. It's not a difference. So I move to the next one. There's a square. It's a difference. Is it a difference of 2 squares? Well, m squared is the easy one. What is 1? 1 is 1 squared. So I need to do another box. And this time, I'm going to put m squared here and negative 1 here. And just like the last one, we're going to go, okay, that one's 1. This is an m times an m. M goes here, so boom. M goes here, M goes here. These two are the same. And I get, in this one, M, here negative M. Add them together, I get 0. So my final answer is 3 times m squared plus 1. This became m plus 1 and m minus 1. And I say, okay, this is the only one that has a square, and I already know it's done. So there's my final answer. So what can I take out of these 3? I see at least I can take a 2 out, and look, they all have at least 2 x's. So I'm going to take 2x squared, and to get this I need 2, got it, x to the 4th, I only got 2 of them, so x squared, plus 2x squared. 2 times 4 gives me 8. And I need 3 x's. I only have 2 x's, so I need 1 more. Plus 2x squared times 6 is, so a 2 times 3 and I need 2x's, got them. So I'm going to take that first number, 2x squared, out. And I'm looking at x squared plus 4x plus 3. This part's done. I can factor this. I'm pretty positive. I'm going to try it because there are going to be times that that won't factor. X squared is x and x. 3 is 3 and 1. Let's see if it works. These are x. These are x. These are 3. Here we get x, and here we get 3x, and add them together, we get our 4x. So 2x squared, x plus 1, x plus 2, or excuse me, x plus 3. Can't do any more to this, and this is just one term, so we can't do anything with it. So that is our final answer. So again, what can I take out of all of them? Nothing. So I count my terms. I've got 4. Step 2 tells me, let's look at 3 terms or 2 terms. Well, we don't. We have 4 terms. So no 2/3 and 3 terms. 4 terms, group it. Okay. So here's 2 together, 2 together. Over here, I can take the x squared out and a 3. The 3x squared, got my 3. I need 3 x's and I only have 2. 3x squared. 3 times 4 is 12, and x squared, so I'm there. Take out your 3x squared. What are we left with? X plus 4. There's a minus. I know I want it to be plus, so that means I need to take a negative out of these two. And looking there, I can divide them both by 2. So negative 2 times x and negative 2 times a positive 4. I'm going to go ahead and make that a positive 4. So here, if I take out that negative 2, I'm left with x, so take out that negative 2, and a positive 4. They both have x plus 4. That's what we wanted, so let's cross that out. The rest goes in the next one. 3x squared, and a plus minus is a minus 2. I have a square. I need to double check that I can't go any further. Well, this is 3 times 1 is the only way we can get 3, so that's not the difference of 2 squares. So that is my final answer. All right, so we look to see, is there anything we can take out of all of them? And the answer would be no. So we group them because there's 4 terms. So when we're looking at these two, what they have in common is it looks like 4 C's. This one has 4 and this one has 6. So we can take out at least the 4. I need to get a total of 6, so that would be c squared. Minus c to the 4th, and remember we need that 1. So let's take that c to the 4th out, and I'm left with c squared minus 1. Remember, whoops, there's a minus. We know we're bringing down a plus, so that tells us we have to take a negative number out. And it looks like all we can take out is 1. So this is going to be negative 1 times c squared, and negative 1 times negative 1, because a negative times a negative gives us a positive. So if we take that negative 1 out, we get c squared minus 1. So they both have c squared minus 1. Take it out, and this is c to the 4th minus 1. Now, the one thing on this problem we've really got to focus on is factor completely. Because if you look at both terms, both parts, both of them are the difference of 2 squares. So c squared minus 1, this is c squared, this is 1 squared. C to the 4th minus 1, this is c squared to the 2nd power, and 1 squared. So let's start with c squared minus 1. So if we bring our box, and we fill it out, all the parts. So the only way to get minus 1 is a minus 1 and a positive 1. C squared would be c and c. So here, 1. Here is c. Here's c. And here's negative 1. And we get a c and a minus c. And when we subtract them, because one's positive, one's negative, we get the 0 in the middle. So for this portion, we get c plus 1 and c minus 1. And remember, that's for the c squared minus 1, and that's going to come back and be helpful in a minute also. So we've got the first part done because I can't factor anymore. But this one, let's do another box. It's a very long problem, not a horribly difficult problem. So don't let the factoring completely be something that you're worried about, because it's not difficult, it's just time consuming. And I'll show you one little step that if you can catch it, you can save a step. So c to the fourth and negative 1. So we have negative 1 and 1. I'm going to try c squared. I usually try the squares. They usually work. 1. This is c squared, and negative 1. So in this box we get c squared. Here we get negative c squared. 1's positive, 1's negative. We subtract. So we get that 0 in the middle, and everything works out. So for c to the fourth minus 1, we get c squared plus a 1 and c squared minus a 1. Now look at what we've already done so far. This box represented c squared minus 1. I see over here, I can't do anything here because it's not a difference, but this is a difference of 2 squares. If you can see that this is the same as this, watch what happens. So we started with c squared minus 1, c to the fourth minus 1. Well, we know c squared minus 1 is exact, kind of like substitution. We know it's the same thing as c plus 1, c minus 1. We know this is the same thing as this. So in place of this, we're going to plug in here, and in place of this, we plug in here. So c squared plus 1, c squared minus 1. We're checking to see if we can factor completely. And as we're factoring completely, we realize this is not a difference, so it's fine. These are not squares, so we're good. Oh, there's a square, and it's a difference. But we already know the answer. Look here, c squared minus 1 is this. So we're going to take this, just like substitution, and plug it in. So c plus 1, c minus 1. C squared plus 1, and now for this we're just going to plug in c plus 1, c minus 1. Oops, c minus 1. Now your book might give it to you like this as an answer. Notice you have 2 of these. C plus 1 squared. Notice you have 2 of these. C minus 1 squared. And then c squared plus 1. This answer was totally fine by me, but just letting you know that the book might actually come back like this.